transforming exponential functions. Transformations include things like shifting up and down, left and right. We could also reflect, and we could also stretch the graph. And so in order to investigate this, we're going to use our basic function for an exponential function. We have a times b to the x power plus c. And I'm going to give you a basic function to start with. So basic function is just a starting function. That's your start function. And we're going to use this one right here. So we've got an a value of 1. We've got a b value of 2. And we've got a c value of 0. And just as a reminder, A is going to be your y-intercept. B is going to be your ratio. That's the number you're multiplying by. And then C is going to be your asymptote. Okay, so let's look at this function right here. We have f of x equals 1 times 2 to the x power plus 0. So I'm going to start at 1, and then I'm going to be multiplying by 2. 2 to the second power, and then I'm going to go up to the 8. If I were to go on the left side, so remember, it's a good idea to do some numbers on the left and the right side of the y-axis. So the examples we've done in the past, I've had you use this table with -2, -1, 0, 1, and 2. If I already can see I've got a 0, 1, and then if I plugged in a 1, I'd have 2, and then 4. But you can see if you plugged in a -1, that's going to be 1 times 2 to the -1 power, and that's going to be 1/2. So if you were to use a calculator for that, you'll see that you get 1/2, so it would cross about right there. And then if I did 1 times 2 to the -2 power, that's 1 times 1/4, or just 1/4. 0.25 would be another way of writing that. And if you're not sure about how I'm calculating these numbers so quickly, you might want to try using a calculator. And then also review rules of negative exponents. So if that's something that you weren't really sure what I did. But you can see here when we look at our parent function that our y-intercept is 1, and then our common ratio is 2, and our horizontal asymptote is this line at the 0. That's our C value. Okay, so what we're going to be doing is we're going to be applying some transformations, and we're going to see how changing a couple of numbers will affect the shape of our graph. And it's probably good to use Desmos for this investigation so that you can see the transformations really fast. So I'm going to go ahead and I'm going to open up Desmos right now, and I'm just going to graph this function just so that you can see really quickly what these transformations do. So let's go ahead and do that. I'm going to graph our parent function. Whoops, I accidentally changed my exponent. Sorry about that. All right, and you can see it matches what we got on our graph right here. So what I want you to think about right now first is what's going to happen to this basic function. When I talk about the basic function, I'm talking about this graph. What's going to happen if I increase or decrease the a value? So I'm talking specifically about this number right here, this a value. What's going to happen if I change that number? So I'm giving you these examples right here. Try changing the a value to 1/2. See what happens to the graph. And then again, try changing the a value to 2 and see what happens to the graph. So let's go ahead and just look at what that would be like. And one way that I like to do this is I like to copy and paste the parent function below so I can like mess around with it and see what happens. So if I change it to 1/2, it looks like it becomes just a little bit less steep. And if I change it to 2, it looks like it becomes more steep. So you can change different numbers. You can maybe change it to a 4th, a 3rd, a 5th. You could try using a decimal like 0.1. Now it's really flat. If I made it like a really big number, maybe like 5, you can see it's a lot steeper. Look at that y-intercept though. Do you notice how my y-intercept changes? So here my y-intercept is 5. Well, notice that my a value is also 5. If I changed it to 1/2, look at my y-intercept. It's also 1/2. If I change my a value to 7, look, my y-intercept is also 7. So there's a couple different observations you can make, but I want you to explain like how does changing the a value affect the shape of the graph. So for this one, I'll go ahead and do an example for you. So for example, if I gave 1/4 times 2 to the x power plus 0, if that's my example, I can say that my y-intercept changes from 1 to 1/4. And then I can also see if I changed it to 1/4 that it's a little less steep. So it doesn't increase as it doesn't increase as the same because it increases at the same rate, but it starts at a lower value. So it's a little bit less each time. And then so you can make up your own example and then just show me. It changes your y-intercept. I mean, that's really the biggest thing that it's doing is it's changing that starting value. So if the starting value is lower, then basically all the points on the graph are going to be lower. Okay, so then let's look and see what happens if we just change the c value. So all we're going to do is we're just going to change that c value. So our original function, we had 1 times 2 to the x power plus 0. That was our parent function, our basic function. And all I'm saying is go ahead and try changing the c value to something else. Like, for example, change it to a 3. And let's just investigate and see what happens. So you can go to Desmos and you can look back at that original function that we started with. So this was my parent function right here. And I'm not going to change anything about it except for I'm going to change the c value. So if I change the c value, look what happens to the asymptote. So here, notice my asymptote is now this line y equals 3. So on my original parent function, my asymptote was this y equals 0. If I were to change my c value to something negative, like -2, for example, now my asymptote is -2. Do you see how the graph gets closer and closer and closer to -2? It flattens out at -2 and it never goes below that line. I could change my c value to 9. And now look what happens to my asymptote. It becomes this horizontal line at 9. So if I were describing this, how it changed, I would say changing the c value changes the asymptote. You might notice also that changing the c value bumps up your y-intercept. So on your original function, your y-intercept was 1, And when we added 9 here, now my y-intercept is 10. So it looks like it bumped it up by 9. If I were to just have added 3, now my y-intercept is 4. So it bumps it up, the y-intercept up or down by however many spaces or whatever the c value is. So if it was -5, now my y-intercept is -4. So it dropped it down 1, 2, 3, 4, 5 spaces. So that's another thing that you might notice. So it changes y-intercept up or down c spaces. So those are just my observations for the first two. I'm going to have you guys try now to investigate on your own without so much guidance what happens when you change the argument and when you multiply the a value by -1, or when you add or subtract a number from the x value. So one thing here, when I'm talking about the argument is just the exponent. So if I were to multiply my x by -1, now that makes it a negative x. And that's what I want you to see. Like, describe what happens compared to that basic function. Always referring back to this is your basic function that we started with up here in the top of our paper. This is a basic function. So when it says compare to basic function, you want to be comparing right here to this first graph. This is our basic function. So when you multiply the argument or the x value by -1, what happens? Describe what happens. When you multiply the a value by -1, so all you're doing is changing that a value to -1. What happens? And then the last thing, what happens when you add or subtract a number from the x value? I don't know what happens. You investigate and you decide what happens, and then you describe it.